So, welcome again to our basic calculus course, and today's discussion will be about chain rule and higher order derivatives. So, effectively, this is just a continuation of our discussion yesterday. So, week 7. When we say chain rule, so it has a little bit complicated notation, but it's just easy when we do the example. So, we have the derivative of composite functions here. So when we say a composite functions, it means a function within a function. So for example, we have a function f of x that is equal to u raised to 5. And then we have u is equal to x plus 3. So we have here two functions, f of x and another function x plus 3. So we denote this as f circle g as the composite function. But you can see that u is just equal to x plus 3, so you can just substitute there. So f of x is effectively equal to x plus 3 raised to 5, something like that. So it's just a complicated way of expressing function, but essentially it's just something like this. Okay. So the chain rule, we already discussed it a little bit yesterday. So we have already discussed the chain rule in combination case. So for example, you have y is equal to 3x plus 1 raised to 5. So in our combination case yesterday, so that is equal to un minus 1, then the derivative of u. We solve the derivative of y prime, then we have an exponent of 5, so we just write 5 here. Then 3x plus 1. Because this is 5, then we subtract 1, so this is 4. And we just get the derivative of that function. The derivative of that function is 3 plus 0. Then we just simplify. So 5 times 3, that is 15. 3x plus 1 raised to 4. Okay, so that's how we do it in combination case, just like yesterday. I would like to emphasize here that chain rule can be used in all functions. So for example, y is equal to, let us say, 4x raised to 3. So if we use the chain rule here, so that would be y prime is equal to 4 times 3, that is 12. Then x raised to 3, so that would be 3 minus 1, that is 2. Then we just get the derivative of x, which is only 1. So it is only equal to 12x squared. Therefore, it also follows the chain rule, but the derivative of x is just 1. So we don't write it at all in a normal situation. Okay? Let us have another example. So y is equal to 4x squared minus 2, then cube. To get the derivative of this chain rule, we use chain rule. So y prime, 3 times 4, that is 12. And then x squared minus 2. Because this is 3, we subtract 1, so that would be 2. And the derivative of this function, x squared minus 2, is equal to 2x minus 0. We just simplify this one and get the final derivative. So 12 times 2x, that is 24x. X squared minus 2, so raised to 2. So this is your final derivative, and I hope this is making sense. Okay? So that is chain rule for combination case, just like we discussed yesterday. We can also apply chain rule in, no, maybe we move to product rule. We can also use chain rule in product rule. So let me give you an example here. Let us have given f of x is equal to 4x minus 5 raised to 5 maybe, plus, no, multiplied by x squared plus 3. We can treat this as u and multiplied by v. So this is our u and this is our v. Then to do the product rule, so we follow this formula. Derivative f prime x is equal to copy u. So that would be 4x minus 5 raised to 5. Then derivative of v. The derivative of v is just 2x plus 0. Then plus the copy v. V is x squared plus 3. And derivative of u is just 4 minus 0. Then we just simplify this one. F of x, f prime x rather, is equal to 2x 4x minus 5 raised to 5 plus 4 x squared plus 3. So that is how we use the chain rule in product rule. Okay? We can have another example here. Another is y is equal to 9x squared minus 4x raised to 2. And then let us have negative 6x. So we can have here this as u, and we can have this as v. So it's your choice. So for derivative y prime, we just follow the product rule. So u, copy u, so that would be 9x squared minus 4x squared, then derivative of v. So our v is negative 6x, so the derivative of that is just negative 6. Then plus, copy v, our v is negative 6x, then derivative of u. Derivative of u is, since this is squared, then that would be 2. Then 9x squared minus 4x. Then because it's 2, we subtract 1. So that's 1 only. And derivative of this one, the inside function is 18x minus 4. Because it's 9x squared, so the derivative is 18x And for negative 4x, that is just negative 4. For our final answer, we just simplify this one. 9 y prime negative 6 9x squared minus 4x squared plus, so here we can just write down negative 12x, then 9x squared minus 4x, and 18x minus 4. So we can have this as our final answer. It's a bit long or lengthy, but it's okay. As long as the mathematics is correct, then we have no problem with it. So for just clarity, maybe I can give another example for chain rule in product rule. The important thing here is that you can memorize the formula because it's a bit long. So if you're new to this, then maybe you can forget some of it. But if you do it a lot, then and keep practicing, you will be able to memorize that. And if you will be studying more of calculus, these formulas are important. So another example is 3x plus 1. Maybe I can give here an exponential exponent, fractional exponent rather. And 4x minus 5, then 3. So I will give here both given with exponent. So this is our u and this is our v. F prime x, follow the product rule formula, so copy u, 3x plus 1, 1 half. Then derivative of v, that would be equal to 3, 4x minus 5. Then because this is 3, we subtract 1, goes to 2. Then the derivative of 4x minus 5 is just 4, then 0 maybe. Then plus, copy v, 4x minus 5 raised to 3. Then derivative of u. So the exponent is 1 half, so we get here 1 half. Then 3x plus 1. Because this is 1 half, then we subtract 1. So 1 half minus 1, that is negative 1 half. Negative 1 half. And then the derivative of this one, 3x plus 1, is 3 plus 0. It's okay with me that you don't write the 0 at all, but for the sake of discussion, I'm writing it. Simplification. So 12, 3x plus 1, then 1 half, 4x minus 5, plus 1 half and 3, that is 3 over 2. 3 over 2. Then 4x minus 5, 3, and 3x plus 1 raised to negative 1 half. When we discussed this in college, we further simplify this one. But since this is just basic calculus, then maybe we can have this as our final answer. Because if we solve this and simplify it further, it gets complicated. But for me, as long as the math is correct, then we don't have problem with that. Okay? So do you have any question regarding chain rule and product rule? You can ask now.
Nothing naman, sir.
Okay.
As far as I'm concerned, naintindihan ko naman.
Okay, that's very nice.
So,
Mm-mm.
basically speaking, it's just a more complicated version lang of the product
Yes.
rule.
Yes. Because we have this
So,
exponents and some parentheses and all.
mhm,
But basically, it's just the same with what we discussed before. You just need to be very careful in
product
solving.
product rule with extra steps.
Yes, yes, that's a good way to interpret it. Okay, because this problem exists in
As
calculus. Any question?
so basically, so in the problem, sir, basically still got the
Mm-mm.
same 3x, and then so find the derivative of 4x minus 5 cubed, and then find the derivative, and then find the derivative of the derivative inside. Ganun po ba?
Something like that. Yes,
Okay.
I think you
Okay.
understand it.
Also, sir, there's a
Mm-mm.
missing cube. There's a missing cube here on the 4x minus 5 at the bottom. I
Okay,
think.
okay. Here,
On the
no,
left side, sir.
left side.
The
Here,
left, the left
no,
4x
the
minus 5.
squared. I think
Squared
here.
pala.
Yes, yes, squared. Thank you for noticing that.
Yes, sir.
Okay, so maybe we can continue for the chain
Yes,
rule in
sir.
product rule. Okay. So for chain rule in quotient rule, let us have an example. Y is equal to x plus 2 cubed, then x minus 1. So this is a given of, this is expressed in terms of quotient, fraction. We can say that the numerator is u and the denominator is v. If we get the derivative of this, y prime, we follow the quotient rule. So this one. So it's a bit long and you need to memorize that one. So to follow the formula, copy v. So that would be x plus 1. I don't know. X minus 1 rather. X minus 1. Then derivative of u, x plus 2 raised to 3. So that would be 3x plus 2. Then because this is 3, we subtract 1. So that is 2. Then derivative of x plus 2 is just 1 plus 0 because that is just x, right? And derivative of 2 is 0. Then minus copy v, I think. Copy u, sorry. X plus 2 cube. Then derivative of v. So derivative of v, x minus 1 is 1 minus 0. So we just, then v squared at the denominator, x minus 1, then squared. Then we just simplify this one. So this is just 1. So we delete that. So our final answer is 3x minus 1, x plus 2, minus x plus 2, then cube, x minus 1, then squared. So we can further simplify this, but I think we can stop here. Because if we try to simplify this one, it gets complicated. Okay? Let me give you another example. F of x is equal to 1 minus x squared, then 4x plus 10. Then let us give this an exponent of 3. Okay. If we get the derivative of this, x prime x, then follow the quotient rule. So copy, this is u, this is v. Copy v, 4x plus 10 cube, and then derivative of u, 0 minus 2x, then minus copy u, 1 minus x squared, and 1 minus x squared, then this one, derivative of v, so this is 3 because the exponent is 3, 4x plus 10, then 3 minus 1 is 2, then derivative of 4x plus 10 is 4 plus 0. Then all over v squared. Our v is 4x plus 10. Because it's already cubed and we give it a squared, so this will be 6 because 3 times 2 is 6. So I'm hoping that makes sense. We have already cube here and we further square it, it becomes 6. Okay. F prime x is equal to, so just simplify, negative 2x for x plus 10 cube, then minus 4 times 3 is 12, 1 minus x squared for x plus 10, then squared all over 4x plus 10 raised to 6. So this could be our final answer. So let me remind you, in the exam, you will be given a value that you need to substitute. For example, if x is equal to 1, then what is f prime of x? So in the exam, it goes something like that. Okay, so what you need to do is just substitute 1 in all of the x and get the final value for the derivative. I hope that is clear. Okay, so maybe last example. Y is equal to 9x raised to 5, then x plus 1 raised to 3. Okay. This is our u and this is our v. Get the derivative, y prime. So copy v, that is x plus 1 cube. Derivative of u, that is 5 times 9, that is 45, x raised to 4. So I'm hoping that is clear. Then minus, do not forget that this is a subtraction sign. Copy u, 9x raised to 5. Then derivative of v, so that is 3 because of the cube. X plus 1, then 3 minus 1 is equal to 2 here. And the derivative of x plus 1 is just 1 plus 0. All over v squared. So x plus 1, because it's 3 already, then we have to square it. Again, this is a 6. You just multiply the exponent because that is the exponent law. Y prime, so we just need to simplify this one. Then we have our final answer. X plus 1 raised to 3 minus, so this is just 1. 1 times 3 is 3. Then maybe 3 times 9 is 27. 27 x raised to 5, x plus 1 raised to 2, all over x plus 1 raised to 6. So this is our final answer for the derivative of u over v. Any question for the quotient rule?
Sir,
Mm-hmm.
clarify lang.
Yeah, sure.
So, in the the left portion, the so you cut the V, how did it become 4x po?
Hmm. This
Wait,
one? Copy V.
yes. Copy
This is
V
9.
derivative,
Hold on.
yes, 45.
This is 45. Yes, yes. Sorry, I'm sorry. This is 45. So this is 45, right?
Yes, sir,
Okay, that's
45.
very good. X raised to
Okay,
4. That's correct, right?
it's the
4.
same. Okay.
Okay, so I'm sorry for that. I missed the 5.
Eh,
Anything
Yes,
else?
okay, sir. Nothing, sir. It's I managed to get it naman.
Okay, okay. That's very good. So we can move along further. So this one is the last part of the discussion for today, and it's a little bit easier. So higher derivatives. So most of the time, when we say derivatives, it means something. It means getting the slope or getting the rate of change. So let me tell you something about physics. For example, in physics we have, for example, distance. So distance. If distance is equal to x, then we get the derivative of x. So that would be dx over dy. So this will be the velocity. For example, this is in meters. So if we get the derivative of a distance with respect to time, so this will be equal to meter per second. And it becomes and it becomes a velocity. So and if we this is y prime, and when we get another derivative which is y double prime, it becomes meter per second squared, and it becomes acceleration. So let me repeat that. Uh, in physics, there's an example like distances. So y is equal to x. So this is distance. Distance is expressed in meters. So that is y. Y is equal to x. And then if you get the derivative of that, it becomes dx over dy, right? So it becomes velocity. So that is the derivative of distance. If we get the derivative of distance, we get the velocity. Then if we derive again the velocity, we get the acceleration. What I'm trying to say here is that when we get the derivative of a derivative, it means something. Okay? Does that make sense to you?
Wait, so sir, parang if we get the derivative of A, it
Yes.
will become derivative, it will become B. If we get the
Mm-hmm.
derivative of B, it will become C, like that?
Something like that, but it means something. You just
Yes.
not getting the derivative, but it means something. Like here, if we get the derivative of distance, you get the velocity.
Velocity.
Then if you get the derivative of velocity, you get the acceleration, something like that.
Sir, question, so
Yes.
it will increase or will it not?
uh it has another meaning, something like that. It doesn't increase, but it has another meaning.
Okay.
It has like As you know, distance is just meter. When you say velocity,
Yes.
it's meter per second. How fast is a
A
object
body
moving?
moving.
Yes. When you say acceleration, how fast is the velocity changing? Something like that, isn't it? And that is rate
Mm.
of change.
Okay, sir.
Yes. Okay. So that's why we need to study higher derivatives because as you move along, so first you need the given y, then first derivative is y prime, second derivative is y double prime, third derivative is y triple prime, and fourth derivative is fourth prime, and so on. So we can do that. Okay. Let me give you an example. For example, our y is equal to 6x raised to 4 minus 6x squared plus 9x minus 1. So this is our given function y. So let us find um, the derivative until it gets 0. So let us try to find that. Y prime is equal to, because this is 6, this is 4, that is 24. X raised to 3 minus, this is 6, that is 2, that is 12. X raised to 1 plus, this is 9, right? 9x, so that's just 9 minus 0. Okay? Then y double prime, so second derivative. This is the first derivative. We will try to get the derivative until it gets 0. So 24 times 3, that is 72, I think. 72 x squared minus, this is 12x, so that's just 12. And this is 9, so that would be 0, right? So it's not 0 yet, so let us go further. Y triple prime is equal to 72x squared. So we get, I think, 144. Then x raised to 1. And because this is constant, we just get 0. And it's not 0 yet, so we can move along further. 144x, so that's just 144. So it's not 0 yet, so our final derivative is, uh, so it reached 0 at fifth derivative. I think there is a question in your exam like this. How many derivative do you need to do for the function to be 0? Something like that. It's just testing you that you can do the higher derivatives. Is this clear?
Yes, sir.
Okay. So this is the addition and subtraction. In addition and subtraction, it's easy. But when we do quotient and product, it's a little bit complicated. For example, let us try
Ah,
this one, okay? Because you noticed earlier that the answer in product and quotient are a little bit longer, right?
yes, sir.
So I'm not sure if in my years of experience in teaching calculus and in application, um, it doesn't it's not appearing in worded problems that often.
Mm.
So I'm not teaching it a lot, but let me give you an example. Okay?
Okay, sir.
Okay. For example, we have, just for the product rule, y is equal to x plus 2 and, no, product rule. Because quotient rule, when you get the second derivative and the third derivative, it gets really complicated. So let us just try product rule. Okay. Then x squared plus 4. So this is your u, this is your v. Let us try to get the second derivative of this one. Second derivative only. So find y double prime. So that's the second derivative. So for the first derivative, copy u, x plus 2, then derivative of v, that is 2x plus 0, plus copy v, x squared plus 4, then derivative of x squared, x plus 2 is just 1 plus 0. Okay. So first derivative is equal to 2x, x plus 2, plus x squared plus 4. Okay. So for me to solve the second derivative more easier, so I will simplify this further. I will distribute here inside. So that is 2x squared plus 4x, right? So I will rewrite this simpler, x squared plus 4. So I will combine some terms. I will combine these two. That is 3x squared plus 4x plus 4. So I'm hoping this is clear. So I did the further simplification just to do the second derivative easier. So this is our first derivative. For the second derivative, y double prime, so I can do it easier. So that is 6x plus 4. So this is our second derivative. So maybe we can do the third derivative here because it's only easy. Then 6, right? Then the fourth derivative is just 0. But we can stop here because we're just trying to get the second derivative. Any question about this one? I'm hoping that this makes sense. Any question?
Nothing naman, sir. I
Okay.
understood it naman.
So I will not give an example of chain rule here because when we give or when we have a problem chain rule and higher derivatives, it's a very, very long process. I'm just trying to show you that for product and quotient, there's also such as higher derivatives, but it's a little bit longer process. Okay?
Mm.
So I'm hoping that it's so for this day's discussion, that is all for today. So that is chain rule and higher derivatives. So for chain rule, it's just a way of solving more complicated derivatives because you have some
Mm-hmm.
parentheses and some exponents. And for the higher derivatives, you just try to get the derivative of derivative and another derivative of the derivative, something like that. And if you get some of that, it means something in a real sense. Just like the distance, if you get the derivative of a distance, you get the velocity. If you get the derivative of velocity, you get the acceleration, something like that.
Okay, sir.
Okay, so do you have any question or clarification about this one?
Yes, sir. So,
Sure.
clarification-wise, I understood it naman.
Mm-hmm.
So, chain rule is basically solving the derivative of a of a composite function. That
Yes,
I get.
yes, yes,
So chain rule and product rule, it's just the same. However, again, since medyo complex siya, we use
yes,
the chain rule instead.
yes. Because here in product rule, for example, this one, we use the chain rule because this has parentheses and some exponent. So in
Mm.
here, you need to do the chain rule, isn't it?
Okay, sir. Same, the same applies with the quotient rule,
Yes, yes,
right? Okay.
yes. Basically, when you see an exponent, a parenthesis with an exponent, you do the chain rule, isn't
Okay,
it?
sir. Yes, sir.
But as I've said earlier, um, the simpler given also follows the chain rule, isn't it? For example, y is
Yes, sir.
equal to 9x raised to 10. So this is a simpler given, but it still follow the chain rule. But it's a simpler problem. So y prime is equal to
Mm.
90 x raised to 9, isn't
9.
it? And then you just
Yes,
get
sir.
the derivative of x, which is equal to 1 only. So therefore,
Yes,
it's
sir.
also follows the chain rule,
Mm. Oh, okay.
isn't it?
I get it. Yes, sir.
Okay,
Yes, sir.
yes. So you just need to take note of that. Okay, so if you do not have any more questions,
Try ko.
then this is the end of our lesson for today.
Thank you,
So
sir.
thank you very much. I hope to see you again next week.
You too, sir.
Okay, so take care.
Thank you. You too, sir. Bye bye.
Okay, bye bye.